You've been introduced to the idea of knowledge graphs as a data structure that stores information in nodes and in the relationships between those nodes. Let's start by taking a look at these concepts in more detail. Come on, let's dive in. So nodes are data records. We're going to start exploring what that really means inside of a knowledge graph by actually just drawing what a graph might look like and talking about how the data patterns within the graph emerge. Here we have a very, very small graph with just a single thing, a person whose name is Andreas. That's me, of course. And if you want to talk about this very small graph, you'd be tempted to look at that nice, kind of round circle we've got there and talk about that in like a Slack channel, let's say. You could use parentheses around the person, and that would mean, okay, we've got a node here, that's a person. So we're going to pay attention to that as we kind of evolve a very small graph. Let's add another person. So now we have this person, Andreas, another person whose name is Andrew. And again, sort of in a text representation of that, we'll use parentheses for each of those persons. Now we have a data pattern that's actually just person, comma, person, the data pattern of a graph that has people inside of it. To make it into a full graph, of course, we don't want just the thing, we want relationships between those things. And these relationships are also data records. We have a person, Andreas, a person, Andrew, and a relationship that person Andreas knows the person Andrew, and knows since 2024. Again, in text representation, we've got those nice parentheses around the nodes, and the pattern here is now not just person, comma, person, but that person dash knows in all caps, and then a little arrow, this other person. So the data pattern that we've established that there's a person who knows a person. So if you remember back to your computer science classes or maybe some math classes you've taken, and you know anything about graph theory, you remember that nodes are often also called vertices, and the relationships that we have here in the data structure might be called an edge instead. Different terms for exactly the same ideas. Now, as a data structure, the reason that we actually use the word relationship instead of edge is that the relationship is really a pair of nodes and then information about that pair. So you can think about the idea that the relationships actually contain two nodes. So here, there's a nodes relationship that contains Andreas, and is directionally also containing Andrew.
To expand our small graph a little bit, we have the idea that there's a person, Andreas, who knows another person, Andrew. And what do they have in common? They also have this course, Knowledge Graphs for RAG, in common.
So we'll introduce that as a new node in this small graph. We know that person Andreas teaches this course. So here's a new data pattern among two new kinds of nodes. There's the person that we already had, and this new course node as well. Andrew also has a relationship to this course. Andrew helped introduce this course. So we both have relationships between the people and the course. And if you look at that in the text representation here in the bottom, this becomes a little bit longer of a data pattern, but you can still read through this, and it's worth taking the time to do that. You can see that there's a person who teaches a course going from left to right, but then on the other side, you have kind of the reverse direction where you read from the outside again, a person that introduces that course. Putting that all together in one line, you then have directions going from left to right, but also right to left, meeting in the middle at that course. A little side note here that I think is interesting when you're thinking about how to data model within a knowledge graph. You could say that this person who's Andreas is a teacher. You could say that this person, Andrew, is an introducer, I suppose. But instead of that, we don't really need to add those extra labels to the people themselves, because Andreas is a teacher because he is teaching. Andrew might be an introducer because he does introductions. So you don't need to add extra labels to the entities themselves, to the things or the people. You can just use relationships for further qualifying what those people are and what their roles are within the graph.
Okay, here's a completed, very small graph with just 3 nodes and also 3 relationships. A person who knows another person, that person is taught a class or teaches a class called Knowledge Graphs for RAG, and Andrew introduces Knowledge Graphs for RAG.
That is our completed graph for this small introduction. Okay, now formally, nodes have labels. We already introduced the idea that we have persons and we have this course. In the knowledge graph, we call those labels of those nodes. Labels are a way of grouping multiple nodes together. So for everybody that's going to be a person, we give a person label. For everything that's going to be a course, it gets a course label. Nodes, because they're data records, also have values, of course. And those values are properties. They're key value properties that are stored inside of the node.
So we know that the person Andreas actually has a property called name, where the value of that property is Andreas. Also for Andrew, there's a name property where the value is Andrew. And again, for the course, it has a title, Knowledge Graphs for RAG.
Because relationships are data records, they have a direction, a type, and also properties. So we realized that we have these knows relationships, teaches relationships, and also introduces relationships. That's fantastic. For each of those, we can add extra information by adding properties to them. That this person knows another one since 2024. The teaching relationship also has a year, 2024. And the introduction is actually for what section of the course is being introduced. So what is a knowledge graph? A knowledge graph is a database that stores information in nodes and relationships. Both nodes and relationships can have properties, key value pairs, and nodes can be given labels to help group them together. Relationships always have a type and a direction. Now you have some idea of what a knowledge graph is, and you've begun to build some intuition about the patterns that describe the structure of a graph. Now let's apply these ideas in code with a real graph of movie data. To do this, you'll use a query language called Cypher. Join me in the next lesson to try this out.